Hello everybody, my name is Keith Klein, if you didn't know that already. Last video we talked about retrograde motion, which is pretty much just the apparent motion of planets in the sky when we pass them. Here on the little binder board thing, I guess you can call it, it says up here the title is the heliocentrism and its history. So heliocentrism is the idea that the sun is in the middle of the universe, or the solar system, and all the planets orbit around the sun, and their moons orbit around them. So we didn't get this, I'd say like we didn't get this model since Copernicus, and Copernicus was an astronomer during the Renaissance. If you guys don't know what the Renaissance is, the Renaissance was pretty much just like an age in Europe after the Middle Ages, of religious, artistic, scientific, historical, mathematic prosperity. So it was like kind of like a golden age in Europe. Kind of like the Egyptians had their golden age, and the ancient Greeks, Chinese. So the Renaissance was a big religious, art, science, math, history period after the Middle Ages were done. And yeah, so that was the Renaissance, if you guys weren't taught that in social studies or history yet. So we're going to be talking about heliocentrism, Copernicus, and Tycho Brahe. So Tycho Brahe is another ancient astronomer that comes after Copernicus, and his story is pretty cool. I might have to make a whole other video on just Tycho Brahe alone, because I can go into detail about it for like 40 minutes. But here is the early version of the heliocentric model. As you see, there's no Neptune or Uranus, or it should really be Uranus and Neptune, because they weren't discovered at that time. Technology wasn't as advanced back then. So we got this model from Copernicus. Copernicus lived from 1473 to 1543, so he lived a pretty long life, and he came up with this heliocentric model, and he didn't publish it until he was on his deathbed in 1543, because he knew that it would go against what the church said about his about the Earth being the center of the universe, and I went into geocentrism a little bit last video as well. But you see we have the sun in the middle, and then the respective planets. So Mercury, Venus, Earth, Mars, Jupiter, and Saturn, the only known planets at the time. And I'll go into another video about how Uranus and Neptune got discovered, because it's actually pretty cool. So Copernicus, as I said, lived from 1473 to 1543. He couldn't reconcile centuries of data from Ptolemy's geocentric model, so he couldn't he didn't agree with it. So he didn't believe that the Earth was in the center of the universe, and that the sun and all the planets revolved around the Earth, orbited around the Earth. So it was kind of like a breaking point to him, to astronomy, because this was like the first heliocentric model that we had. So like Ptolemy's model couldn't predict where the planets were going to be in the sky, like every astronomical model there has ever been, like the like if you go onto the App Store, there's a bunch of apps you could buy, like Skyview Lite I have, and Night Sky View is another good one. And those all tell you where the respective planets are in the sky. So I'll leave a link to that in the description. So he noticed that the planets couldn't have orbited around the Earth because because he damn it because all right, here's Kepler. Okay, so he didn't believe it because he noticed that there was parallax, very little parallax back then, because you need like big old telescopes to notice any appreciable parallax because the stars are so far away. And obviously this is not to scale because the sun is not that small compared to Mercury, Venus. I mean, if you look at the sun in the sky and then you look at Mercury and Venus, I mean, you're barely gonna notice them. That's why you gotta look at them when they're in the just coming over the horizon or just dipping below the horizon. So as the sun's rising, you can see a glimpse of either Venus or Mercury, depending on where they are in their orbits. You could either see Venus first or Mercury. So this today, which is the 20th of October, 2022, you could see Mercury comes up above the horizon before Venus because Mercury is closer to Earth in its orbit, and Venus is more towards over here or over here. Yeah, it's a little fun fact for you. So Jupiter has been especially well, I'm going off track, but Jupiter has been especially well at the beginning of the month, and so has Saturn. Sometime this month, you would be able to see Jupiter Saturn, I mean, directly in front of you. I was looking on my parents' balcony at around 10:43. I think it was the 4th of October. I was looking at my balcony, and it was just as high as the moon was, but the moon was more like, so if I'm gonna draw this real quick for you. If I'm looking at my balcony, the moon is like right here, Jupiter's right next to it. I'm just gonna label it so it's easier for you guys to see it. Not that, you really need to. So Jupiter was very well. And then Saturn was also very well. So Saturn was like right directly north. It was really cool to see because that's the first time I saw planets ever, because I just got into this recently got into all this astronomy stuff. So there's obviously other things in the sky like stars and constellations, but this is pretty much what I saw from the balcony. This is much like a model of This is much like an astronomical model called the it's called the celestial sphere, or like it helps you find your latitude. So I guess we could say it's this you could say. So like you draw like a circle. Let's see if I could do this on here. So you draw like a circle. I'm gonna draw a circle. So you draw a circle like that. Like that, you draw a circle there, and then you get the edges, and then you make a dome. And let's say, the observer is right in the middle point of that circle, and then you made the dome. So there's right there's the ground, there's the arc, and I'm gonna label this north, east, south, and west. Nobody eats soggy waffles, or Neswa, as I like to call it. So here it would be one of the equinox days where where nighttime and daytime would be equal, because like let's say the sun would be here. Let's say there's the sun. You're looking at the sun. You're gonna want to find that angle, so you're gonna get I forgot what it was called, but it's used to find your latitude. So if you look at, let's say Polaris is directly north, so let's put it at like, I don't know, like 30. I assume that would be 30. So there's Polaris, the North Star. Polaris, you put it north, you find, I'm actually gonna get a better like example for this. So like, if you're sailing on a ship, you're going to use this device to find Polaris. So like, let's say Polaris is right up there. And that's how you're going to know, like Polaris, you're going to see Ursa Major and Ursa Minor. The Big Dipper is in Ursa Major. So you're going to see Polaris directly your latitude. So if you look through, I made one of these actually. You take like a protractor, and you put a fishing line or a piece of twine, a fishing hook, and then you look through like a little eyeglass, or you just look at the base of the protractor. So that's a terrible protractor. So you look through right here, you're holding it upside down, you look through it, and then the fishing line and fishing hook are going to be dangling right here. And then you, however high up it is, so like the protractor would be like that. So the protractor would be like that, and then you'd have the fishing line, and then the fishing weight. So you'd have the weight, and then like a glass of some sort, or you're just looking on that line right there. And then it calculates your latitude. So in this model, it would be like right there. So I'm gonna guess if it's, that would be, if you're standing right here, this would obviously be in the northern hemisphere, because in the southern hemisphere, the Polaris, the North Star, would be underneath the horizon of the Earth. So, you know, if you're here, you'd see a whole bunch of other constellations and a whole bunch of planets, not new planets, but you'd see the planets at a different time than people on the northern hemisphere. So you wouldn't be able to see Polaris, because let's say you're here in Australia or wherever this is. Polaris would be up here, and your vision would be blocked by the curve of the Earth. So that's a little lesson on if you want to find your latitude, you just look at Polaris. If you don't know where Polaris is, you look at Ursa Major and Ursa Minor, and you look for the Big Dipper. It'll point right at it. Ursa Minor, I find, is better to look at it. So you have the stars and then the Dipper part of the Big Dipper. It'll point right at Polaris. This is Ursa Minor. My handwriting is not that well, but you know, Ursa Minor, and then you'll look right at Polaris. So anyway, back to Copernicus. I don't know why I strayed so far away from Copernicus, but Copernicus made the first heliocentric model, and it wasn't good. Well, it was good because, you know, progress and technology advancements during the Renaissance, and, you know, strides towards modern day telescopes and whatnot. But it couldn't calculate where, you know, like Venus or Jupiter would be. So like his model would calculate that Jupiter would be up here, but Jupiter would be down here, or Saturn would be like here and it would be like here or something. So it wasn't that good of a model in terms of finding where the planets like were. And he also couldn't explain the lack of parallax that the ancient Greeks observed during their time as the leading astronomical group. But other than that, he did propose this model not knowing how far away Earth was to the sun, or how far away, or how big Earth is, or how big the sun is. But this is a step in the right direction, so to speak. So yeah, that's Copernicus. Copernicus published his book when he was on his deathbed. I think I already said this, but he published it on his deathbed because he didn't want to be killed or banished from... I forgot where he grew up. I forgot where he lived. I forgot, a bunch of stuff about him, which I probably shouldn't have forgotten. But he didn't want to get in trouble with the Pope and the Catholic Church because it went against what the Pope said, and if you go against the Pope, it's like going against an absolute monarch. So here's Copernicus's model. I'll go into depth of Copernicus a little more when I find the notes. But we're going to take a look at Tycho Brahe right now. So Tycho Brahe is very cool. He was kidnapped by his uncle when he was 2 months or 2 years old, and his parents didn't go after him because I don't really know why, but he was raised by his uncle. He got into a duel with his cousin and got his nose chopped off, and best friends with a midget, a moose, killed the moose and then died. Got banished by the Pope before he died, banished to an island, was given a whole lot of money by the king to make an observatory, and he was doing naughty, dirty things to the king's wife at the time, and then he was invited to a dinner party where he was a drinker. He was a very big drinker, and he needed to pee, and it was said that he died of blood poisoning from holding in his pee for too long, because back then it was you finish eating when the king stops eating, and then you get up after the king gets up. So we don't really know the cause of his death. It could have been bad chemicals from his prosthetic nose that he got. It could have been the king poisoned him because he was doing not so family-friendly things with his wife. Or it could have been blood poisoning from holding in his pee. But here is the model that Tycho Brahe came up with. So if you can't read that here because it's too smudged together, it says the Earth stays stationary, so the Earth doesn't move here, but the sun orbits the Earth and all the other planets orbit the sun. I tried my best to draw it, but as you can see, it's still a mess. But I don't really know what he was going with here with his model, but I mean, you see it was Mercury, Venus, Mars, Jupiter, and Saturn. So this was dismissed very, very quickly by the group, by astronomers and the Pope, because I don't really know. He was friends with the Pope, so when he proposed that the Earth wasn't the center of the universe, the Pope exiled him to an island where he got a bunch of money from the king, the prior king, from the one he was doing things with the wife. But yeah, here's Tycho Brahe's model. Tycho Brahe actually said the reason why he got banished was because he said that the heavens weren't perfect and they were always changing, because he observed a supernova in Ursa Major, or another part of a constellation that I can't remember the name of at the moment. He saw light from the celestial sphere. If I can just get this off. He saw a light when he was observing Polaris that wasn't there before, and he then concluded that the heavens, or space, was bigger than we thought, and changing, and not unchanging like the Pope and the Catholic Church thought back then. He did comprise, that was his geocentric model, where the Earth stays stationary and doesn't orbit anything, and the sun orbits everything, and the planets orbit the sun, which orbits the Earth, and the moon orbits the Earth. It's confusing, but it was Tycho Brahe. So he was looking in a little island in Italy, where he had all of his things. He had a moose and a midget friend. So northeast, south, and west, not northeast, south, and west. Okay, so he was observing the constellation of Ursa Major and Ursa Minor, and he saw Polaris. So we'll just label that P for Polaris, and Ursa Major, which would be right here. I'm not going to draw the whole thing. So Ursa Minor, well, it would really be over here, actually. So it would be over here, and this would be another part of a constellation. This is not the full constellation, and it would actually be more like that. So it's like a W shape in the sky pointing at Polaris. So we have two constellations that never dip below the horizon, and Polaris, which they point at. So he saw a supernova. We don't know exactly where, so I'm just gonna infer that he saw it somewhere in here, or Ursa Minor or Major, or they both point at Polaris. So this isn't Ursa Major or Ursa Minor. This is another part of a constellation that I forget the name of. It makes a W in the sky, points at Polaris. Ursa Major or Minor points at, because when I try to look for Polaris on my Skyview Light app, I always think it best to look for Ursa Minor rather than Major. So he saw a supernova, and that was like a dim little light, or like a big light, because supernovas are massive and energetic as hell. So he saw this supernova when observing Polaris, and he then concluded that the stars are much further than anyone else anticipated or thought. So he published this in a book, and since he was friends with the Pope was like, bro, you can't. He was like, you can't do this, because it goes against what I say, and I'm always right, and we're gonna banish you to this island in Italy, where he did grow up. He grew up in Italy. he forgot, but he did do most of his work there. As I said, he hired a midget, killed a moose, because, you know, he didn't have many friends. Because why would you hire a midget or a dwarf that would live under his dining room table? And his house was massive. So he observed this supernova by Polaris and wrote a book about his findings, that the heavens are unchanging. Tycho Brahe lived from 1546 to 1601, I forgot to mention. And he also believed that the heavens are more complex, or space, outer space, far space, deep space. The Milky Way galaxy is more complex than previously believed. And he, he spent most of his life working in his observatory and house with his little midget friend and his moose that he gave alcohol to, got drunk, fell down the stairs, and died. That's how his moose died. Thought you'd like to know that. He built instruments he designed and built instruments for greater and further space studying than ever before. So I forgot what he built, but he did find a passion for astronomy at a very, very early age when he was living with his uncle. He made very, 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 very detailed measurements of the planets. I wouldn't say they were accurate. They were more accurate than what's his face? Than Eratosthenes, I think his name was. I think his name was Eratosthenes. Yeah, he definitely did better than Eratosthenes at finding the what am I doing? So he figured out that the okay, so let's do that. The tape there, yep. He figured out that the heavens were were changing and imperfect, which went against the church. He had a moose. I told you this. If I can find the damn page. It went against both Copernicus's and Ptolemy's models. So Ptolemy's model was just the standard geocentric model with the ellipses, with the the parallaxes, and it was they called it Occam's razor, which is a pretty weird name. But Galileo, jumping right into Galileo here, because I've run out of things to talk about Tycho Brahe. My astronomy teacher would be very upset. But Galileo, he observed that the sun had sunspots and that the sun was not perfect, and the sunspots on the sun. Oops. The sun spots changed position. So one day it would be there, the other day it would be like here or there. So so the sun would forever be changing, and the sun would change, and it would rotate. This is proof, because sunspots don't in itself move. The sun would rotate. Because it does revolve around the center of the galaxy, but that's for another video. So we noticed this, these sunspots, because like he was looking at the sun through a telescope, which was pretty stupid of him. But then he reflected an image onto like a wall or a floor, and then he noticed that the light of the sun wasn't like perfect. So this, like, he would see like his telescope's like right there, and he would see all this. He would study and observe this area in the sun, and he would notice that the image that you don't see all the sunspots because the sun's too. You wouldn't see the sunspots because the sun's too bright, and it would hurt your eyes if you look at it too long. That's what he did. He made that mistake when he was looking through the telescope, but then he displayed a picture, and the sun was like not as light in each spot. So what he did was he proposed that the sun was not perfect, but then he was looking at Jupiter one night. So this is just gonna, Galileo, so he was looking at Jupiter through the telescope, and he saw this Jupiter, with a higher frequency telescope, or like a higher grading telescope that could see further. He saw 4 white dots of Jupiter around Jupiter, and these would be known as the Galilean moons. And I don't actually have the I don't have the names of these moons. I know one's Europa Ganymede Io, and I forgot the other one. But he noticed that things rotate around other objects in the sky. So Earth can't be the center of the universe if, Jupiter has these balls of light, or the Galilean moons, and we've come to discover much more than just these 4 bodies around Jupiter. But it would prove that Earth is not special in the sense that it has 1 moon, and Jupiter saw, and Galileo saw 4 objects orbiting Jupiter, and he saw these moons. He saw these lights that orbited Jupiter. He saw them change in their position. So we'd see 1 like here. He'd see 2. He'd see 3 some days. He'd see since the sun shines the light, when he was saying, so it's like upside down and backwards in his telescope. So the sunlight would come from here, and then that means the dark side of the moon would, the Jupiter would be right here, and then you wouldn't be able to see the moons if Jupiter's shadow was blocking them. So much like a lunar eclipse on Earth, if the Earth's shadow gets in the way of the moon and the sun, we get a lunar eclipse. If the moon gets in between the sun and the Earth, then we get a solar eclipse. But Jupiter's so big that its moons all experience the eclipse pretty much every time they go to the dark side. I don't well, because Jupiter has such a large shadow, and it's so big that it casts such a big shadow that all the moons in comparison are, excuse my lack for a better word, engulfed by the shadow of Jupiter when they orbit. Because during the span that he was seeing, he wouldn't be able to see Jupiter move, because Jupiter has such a long, he has such a long it has such a long orbital period that he would only be able to see the moons, and the moons have much shorter orbital periods than Jupiter does. So some nights he'd see them, there. Some nights he'd see two of them, so like that one would be gone, or like that one would be gone, and then this one would go behind Jupiter and then re-emerge back over here. But you can't see these four moons, the Galilean moons, without a telescope. I'd say a cheap $50 telescope from Amazon would be sufficient for these. So, yeah, I mean, that's pretty much the video. I've been talking about astronomy for like a half hour already. So I'm going to end the video off here with Copernicus, Tycho Brahe, and Galileo. Next video, I'll talk about Isaac Newton and astrophysics by William Herschel. And he discovered Uranus, and in the process discovered Neptune. So that would be next video, which will be sometime tomorrow or the next day. But yeah, there's Tycho Brahe, Copernicus, and Galileo. Oh yeah, I forgot to say this. These are not in order, by the way. I tried to go in order, but then I also missed Johannes Kepler. But Galileo was actually a contemporary of Kepler. He was continuing his work. He was the first person to use telescope to study space. And he discovered that the moon had features similar to that of Earth's. Because when he was observing the moon in the sky, he noticed that the moon wasn't smooth. Like if you look at the moon, it looks kind of smooth. But when you look at it through a telescope, you see it has a bunch of craters, mountains, valleys, and canyons. So he knew that the Earth couldn't have been special if its own satellite was, and I'm saying satellite as in like a natural satellite. So, like the moon, Europa, Io, like we would be considered the sun's satellite. But he noticed that if the moon isn't perfect, then Earth can't be perfect. Like if the moon is all bumpy and not smooth like Earth, so like the moon has a bunch of craters, hills, bunch of valleys and stuff, and Earth, if it's like it's mountains and valleys, it's all there, but the only thing is the moon doesn't have an atmosphere and it doesn't spin, and it has no oxygen or air around it, hence the no atmosphere. Yeah. So those were three very important people in the history, I'd say, of the studies of space and astronomy, and I'd say the introduction to the heliocentric model, which I can't seem to find right here. So you could thank Nicolas Copernicus for this lovely model displayed in front of you. But yeah, if you enjoyed, subscribe. If you want to see more videos like this, they're pretty low quality, and I am not a teacher, so I stumble on my words and whatnot, and I go off notes that my astronomy teacher gave to me. So yeah, that's the video. Like, subscribe, want to see more, comment it, and I'll see you in the next one.